Morning, everyone. Can you hear me online? Do you want to just chat in the chat box to let me know you can hear me? Anyone? Oh, I'm guessing either you can't hear me or we're waiting for someone else to chat.
Yep, I can hear you.
Ah, perfect. Great. Excellent. So thanks for joining us this morning. My name is Tom McKenna. I'm the Technical Business Development Head for the Utilities vertical here at Spatial. And today the subject that we will be looking at is asset inference. So a webinar called Vive la Inference, Revolutionise the way you use your network. So a little bit about Spatial itself. So we're a spatial data solutions provider with a headquarters here in Cambridge. And we've got offices globally, so based in the US in Washington, in Australia, Sydney, in Ireland in Dublin, and across Europe in Paris and Liège. We are technology partners of some of the leading kind of data hosts and geospatial experts around the world, so names like Oracle and Esri. And we're also third-party vendors for some other smart technology such as FME, which is the kind of supplied by Safe Software, and GeoCortex, which is supplied by a now rebranded Vertigis. Our key sectors, but by far not our only area of expertise, is in the government sector, so looking at kind of central data hosts and military. Utilities, which is obviously where I sit, so trying to help global utilities find efficiencies through their spatial data, and transport. And there's a list of some of our kind of key customers down there. So big names like the OS and the US Census Bureau, who are big data holders, and so we process quite a large extent of data. And just before we get into the crux of the problem, in your control panel, you should see next to your name a little hand. If you do have any questions throughout the webinar, you just want to click on that. It's effectively like raising your hand in a classroom, and we will come to you at the end, and you can ask a question, and I'll answer it the best I can. So the background of why we're talking about this subject today. So utilities are kind of data-driven organizations where a lot of the decision-making that happens in them, the operations side of the business, comes from kind of calculated decisions that are made off data processes. And as Clive Humby said in 2006, data is the new oil, and here at Spatial, we're a firm believer of that. As we're going into this kind of digital future, vast amounts of data is being gathered by pretty much almost every organizer across the planet, and in particular utilities who are being asked to do twice as much with twice as few resources. And so they're deploying increased kind of data gathering tools like sensors across their network to try and get a better picture. They're investing heavily in kind of GI technology to try and drive more informed decision-making processes and try and find efficiencies through the current processes that they currently undertake. And we believe that they're right to do so. I mean, they're responsible for often vast networks of both underground and overground assets, and they are kind of given the responsibility of looking after some of our most precious commodities that are kind of key to the running of a country, really. So we can't live without water. Everything we do, including this webinar, is powered through electricity, and we go home to our nice warm homes through the help of gas. To manage these fast networks, utilities often turn to kind of enterprise asset management systems. And these systems are designed to try and, in the best capability, consume vast amounts of data that is spread across the organization and interpretate it, conflate it, and try and almost produce reports or indicators that help the utility try and manage these vast physical networks, but in a digital way. One factor that feeds these EAMs is your spatial data, often visualized in something called a GIS, or geospatial information system. And this provides invaluable kind of information to the organization and allows asset managers, operational managers, field users, desktop users to try and get kind of valuable insights into the specific workings of their physical network, as physically trying to manage these assets can be quite a handful. So that raises a question. Utilities have always pictured themselves as asset management organizations, and that is still very much true. They are managing vast amounts of physical cable, pipe work, physical structures, but are they also data management organizations, trying to manage the vast amounts of data that they have, whether it be in central repositories, data silos across the business? It all needs kind of managing in a structured way that allows them on the asset management side of the business to maintain and allow the smooth running of those assets, again looking after those precious commodities and delivering on the ever rising expectations of their customers. So the importance of spatial data in the running of a utility. So the ERMs we mentioned take a central role in trying to manage and analyze these potential inputs and the risk associated to the network. So utilities are increasingly searching for ways of being more proactive in if we identify kind of strikes, so water leakage, electricity cuts, and gas loss of supply events, and to try and be more proactive in preventing than reactive to ceasing an event that's already happened. And this analysis obviously boils down effectively to the kind of value of the data that you're putting in. You can consume multiple sources of that data to try and get a kind of a best picture of what we're trying to achieve. But the classic saying of poor data in, poor results out applies. If your ERM is consuming data that is inaccurate or untimely, the results you get out, as to the best of the ability of the EAM, it's going to be the decision that gets made out of the back of it is going to be the incorrect decision simply because of the information that you're relying on. And this is where we feel asset kind of inference can come in and play a critical part. So location is critical for a network. To be able to manage these physical assets in the field, it almost goes without saying, you need to know where they are. You need to be able, if there is an incident on a particular asset, you need to be able to get into the field and quickly and accurately kind of operate on that section of, let's say, pipe work to seal a leak or prevent the escape of gas, whatever it might be. All critical, especially when you consider with gas in particular, the dangerous nature of the substance, or with water, the ever-increasing fines that are being issued by the regulator for the escape of water. However, these operations, both field-based and the decision-making process that is happening in the office, can be misleading or can be inaccurate because of missing inaccurate data. So that's why here at OneSpatial we feel that kind of missing asset information is a problem that we can address directly through the solution that we have readily available, and can also have organization-wide benefits. So why did OneSpatial think that an asset inference solution would be a worthwhile investment? So utilities receive grants from their regulatory bodies for electricity and gas. This is Ofgem. For water, this is Ofwat, for the maintenance of their network. And it's important that these grants are accurate, simply because this money is given to a utility to manage promises made to the government. However, inaccurate reports can be costly. Southern Water found themselves being hit with a £126 million fine for inaccurately reporting the quality of the water that they were supplying, and Cadent found themselves hitting a £44 million fine for missing kind of non-asset information. So it's critical that we know, where the location of these assets are, the accuracy of what's happening within the network, and all the kind of missing information can lead to some quite severe fines. And so far on the web, I've been talking about kind of assets, so network assets, but non-network assets are critical too. So an area of concern may be the location of properties in relation to your network, and the type of properties and the number of residents of that property, which may affect your risk scores or how the utility tackles an issue in that area, or in the case of an incident, how they should respond to that particular incident. And not having that missing information and treating the incident differently than it should be can have severe consequences. So how can OneSpatial help? So OneSpatial looks and believes in a kind of rule-based approach. So we've built a spatial rule-based solution that can help tackle most of this kind of missing data issues. Through the methodology that we've developed, we can highly accurately infer kind of asset locations, provided that we can build a kind of true picture and a true value statement from the utility. So we work collaboratively with the utility to try and identify those key features and those key business rules to infer if an asset was to be laid somewhere, where would it be laid? And we can use kind of knowns, so driving off known network locations, and kind of then infer the rest of the kind of location for that stretch of pipe. Or we can look at simple things like when the houses were built and the kind of stereotypical location of particular points, delivery points in particular in the house, to infer, okay, where does the particular feed come from, where does the output particularly go to, front, back. All these type of bits of information can feed in and build a pretty accurate picture of where these kind of inferred assets might be. And also it's an excellent exercise working with the utility to try and identify where in the business key critical data sets might sit. So in our experience working with quite a lot of the utilities across the UK in most of the sectors, is there are data silos in the business that could hold business critical data. But one side of the business may not know of its existence, so they miss out on taking advantage from it, so that's missing value. Or they might go out and even procure a very similar data set from a third party, which the utility then will incur a cost, which is also almost duplicate data, as this data may already exist somewhere else within the organization. So this exercise, working with them, really helps kind of remove those data barriers, remove those kind of data silos, conflate information, draw on multiple bits of information. So not just focusing on your GIS spatial data, but also exploring what other data kind of repositories, such as your SAP systems, can add value, can be associated to, and then can drive the inference process to an even more highly accurate point. And as I mentioned, the solution we have here is a tried and tested evidence-based approach. We've worked with a number of utilities, some that we have, I'll give you some examples of later, and the success stories. But working collaboratively with these utilities really builds kind of like a rule set that is kind of drawing on the knowledge of experts from across the industry, and building on a kind of, as I said before, a business critical understanding of data sets. So we're able not only to provide a solution that is kind of fit for purpose, and is kind of ready to be rolled out, but also kind of applies additional logic to the network model, which may help in kind of increasing that accuracy of inference. So the solution, the one spatial asset inference solution. So I'm just going to try and break this down into the kind of components of the solution, and talk you through what some of the simple high-level indicators, what it tries to do. But of course, every utility handles its data slightly differently. So it's important through, as I mentioned before, that collaborative process, we're able to easily and simply adapt the model or the process to kind of conform to that business, conform to the way that the kind of process internally for each individual utility is handled. So I'll talk a little bit about that as well in our experience. So at the center of the asset inference solution is one of our products called OneIntegrates. And OneIntegrate is a kind of rules-based engine, almost a silent partner that sits at the center of the solution, and processes the information, runs the rules, then kind of applies the actions for the output to come out as these inferred assets based on that driven knowledge that I mentioned previously. So what the engine does is it connects to the enterprise systems I mentioned at the start, and conflates as much information as the utility and we think that we can drive kind of information from. So these data sources can be like your stereotypical types, like your Oracle, but also we can get in some Esri formats. We've got shape in a kind of file database down there, looking at kind of your more open source Postgres, and then your DWG. So it's conflating all those kind of informations into a kind of a single data store, a temporary data store that sits inside the engine itself. So a record isn't just a GIS record that's been consumed from your Oracle. You can add further enrichment to it, building this kind of temporary schema, and drawing on things like your CAD information. Once it's kind of loaded into this kind of central repository, and each record has been updated with its according kind of partner information, if you like, from these external data sets, you can run multiple business rules for both spatial and non-spatial data. And this is important. So the spatial data drives on location, as it may indicate. But as I mentioned before, the non-spatial data that is associated to that asset can be as critically important. Knowing the location, so you can go and excavate a hole to find the asset, is only half the value of the solution. The solution can also indicate critical things like materials, or the pressure of the asset, or even at some points the type of the asset that it is. It's hugely important for field agents and the efficiency of kind of a field-based operation that these non-spatial sources of information are readily available. If I'm going into the field and I'm looking to kind of work on an asset, I take a set of tools with the assumption that it's a particular material and a particular pressure, and when I get there, either through my field knowledge, I can ascertain that I brought the wrong equipment because the GIS information that was supplied to me was wrong, so I have to fill in the hole, go back to the depot, and come back up with the correct equipment. Or for maybe a less experienced individual, or maybe there's been a change to the pipe itself, starts excavating and working on that asset, and soon finds out that some of the metadata was incorrect, so the pressure was wrong, for example, can lead to severe consequences. And also the important thing, as I mentioned before, the data and the network the utilities have can be vast, and it's ever growing as they deploy more information gathering sources across the network, like sensors. So the solution is completely scalable. It can be added to. You can add to the power of the engine as increased information comes in. So a big thing at the moment, particularly in the water industry, is they're trying to deploy kind of acoustic monitors across to try and detect or advanced detect integral damage to assets. That information needs to be stored somewhere. That information needs to be conflated against that particular asset. So this is what this kind of central part tries to do. It tries to take multiple sources, assign it to the correct asset, put it in the right location, and from that, knowing that you now have a trusted, complete, timely set of data, business decisions or operational decisions can be made with confidence. So the capabilities, what we try and do, when we look to kind of deploy the solution, we understand that the business can't stop. The business needs to keep running based off the information, the best information it has to hand. So what we try and do is we're trying to integrate the kind of our validation and correction process as part of the solution, as almost like a pre-check. And as bits run through, we are building a better picture, building a better state. Or simply, if the asset data is already in an excellent state, maintaining that quality and looking to improve that as the asset kind of holding grows or as more information becomes available, making sure we kind of maintain a quality standard for our data. So the validation part, we're looking at, again, working with the utilities, trying to kind of derive what it makes good data, what makes good processing information for your business purposes. And we try and flesh out a series of rules that say, okay, so this information must conform to this standard because of health and safety, because of a timely, because of financial, whatever the reasoning, but it must conform. So we design those rules around those kind of business critical standards. And also provides confidence. So we know that the information either being captured or the information already in the system is being QA'd pre kind of use by the business. And this part is automated. So we try and automate as much as we can. So instead of having your resources tied up QAing parts of the network, with the ever increasing demand for utilities and the restriction on resources that are allowed to deliver it, it's critical that we can have those individual human resources, if you like, doing other parts of the efficiency process. So expanding on further capabilities, so reassign them to other areas of the business to kind of further the capability of the utility without having them stuck on corrections. Then it's the correction bits. We flagged it during the validation part and said, right, this is an issue, it needs investigation. So while there is always the less than 5% of unusual circumstances that may require that human resource to go in and do a manual check themselves, because it's an unusual setup. Because of some reason they've had to slightly go against what the standard should be to fit the kind of physical restrictions on the ground, and that will always be the case. But we would always look to kind of automatically fix up and correct that 95%, allowing, again, as I said before, the resources previously tied up in that to go and find other efficiencies in the business. And being automated, that entire process is completely repeatable. And it's subject to those strict kind of data quality standards that we've identified with the business, as this is the level of conformance, this is the level of confidence that we have in our data, and we want that to be maintained not just now. So it's not a hot one-hit wonder. So in 2019, our data is well trusted, but in 10 years' time, data discrepancies have creeped in either through catchment or during other processes. But we've maintained it and we've improved it. So more rules have been brought in, more kind of correction actions have been brought in. And all of this is in the utility's complete control. So the solution will be built well, deployed collaboratively with the utility. So they will have the capability of saying, right, we've got a new rule, let's design that rule. So the utility can take control of this process and kind of own or date or steward how it looks, what they do with it, and what information is kind of inferred from it. And then there's the enhancement. So the key bit here is the inference. What we would do here is we would look at the kind of data at the start and say, right, we've got a good look at the data now. When 95% happy that it's of a standard that we can trust, and it's at that point where we say, okay, this data is trustworthy. From this, we can derive new information because we know it's going to be of the same kind of data standard as the 95%, 90% we're working off. And this is where the kind of criticality comes in of, I need to know the length of network that I report because I get a grant on it. If I'm missing, for example, all my service pipes, that if you kind of add up all the length across your entire network is a significant amount of pipe work that you may be missing out on, that you may be responsible for and not getting the grant to cover. So it's a cost to the business. Non-network assets, so the location of particular properties, is important again. So if I'm doing a risk assessment on an area that may influence my capital replacement program, and I'm unaware that a new multi-occupancy building has just got up on a road, that may skew my risk assessment, and it may lead to me prioritizing the replacement of an asset in another area when actually the risk of the comparable area is greater because of this new construction, because of these this house that's been turned into 3 flats. So we no longer have 2 people living there, we now have 6, and it will influence that process. So it's critical that we know this information, both where our assets are, the materials, the pressures from an operational side, but also from a health and safety side for particularly on the pressures, we want our guys operating correctly, and the health and safety side of our customers. So where are our customers? How many people would lose supply if we had a cut in the area? How many people are putting at risk if there is a dangerous substance kind of leak in the area? So business critical. And what's the advantages of taking our kind of validate, correct, and enhance process? So as I mentioned before, the process is completely automated. So you can run this at any interval of time that you like, and it's also allowing you to find efficiencies in the business by reassigning them to other areas. It's repeatable and traceable. It's completely repeatable and traceable. So we can look at repeating the work at any interval, as I mentioned before. We're also encoding and knowledge sharing. So we're finding ways of extracting information from the business, those business critical people. So in this particular one, I've been amazed by working with engineers who have a vast amount of knowledge about the network, how to operate on it, and where assets are. Even in some cases where they know assets are physically, it's not represented correctly in the GIS that they take out, but because they've got this knowledge, because they've got this understanding of the network, they automatically know where they need to kind of extract. But then this information is not passed on to the GIS. That information is effectively lost to the rest of the business. And when let's say that lucky individual wins the lottery and moves to Spain, all that kind of knowledge is lost from the utility. And the kind of aging workforce is a thing that utilities are looking at. How do they combat, how do they maintain that knowledge as the old guard move into retirement, or in our lucky lottery winners move to Spain is the case, and how do they enable the new, in this case, engineers coming through to benefit from all that information, to benefit from that wealth of knowledge that they have. It's targeted, so it's not an EAM, an asset management, enterprise asset management system that is all singing or dancing. It's a solution that is targeted to a particular problem. So the missing assets off your network and how those missing assets can have an impact on your business. It's evidence-based, so we work with utilities from across sectors and try and enrich the process by saying, okay, so through collaboration with particular sectors, we know that this is a stereotypical kind of example of what would happen. So we can enrich the process, and the more utilities we collaborate with, the more those benefits are realized. And as the solution is in control, is under the control of the utilities, they can like design that process, build on that process, and really take control of the effectiveness of it as time goes on. And it's effective collaboration. So not only do OneSpatial collaborate with the utility, but it also gives utilities the opportunity to collaborate with each other, learn from each other, which is something that the kind of push is really trying to encourage with the kind of shared underground assets program. But what are the benefits? Why would you, having listened to me for the past half an hour, look to deploy OneSpatial's inference solution into your architecture? So the big one is there's a massive reduction in costs. So for a single solution, you can have organization-wide benefits, whether it be kind of driving those field operations, making in-house decisions based on assets, helping that risk analysis process, trying to reduce the amount of kind of financial penalties that you see from the regulator for missing information or the escape of the commodity that you look after. And it also enables you to kind of enhance those tasks, so improving, empowering the individual making those processes to make that decision of trusted data. And that's particularly relevant for field users. So I mentioned before, know that sometimes the GIS is wrong, but they're able to kind of work around that because of their field knowledge. But with the kind of accuracy of it, it may help help individuals who are looking for assets where the GIS says it is, but they may be 2 meters off. It helps them kind of make those field decisions in reducing duplicate site visits, reducing the expenditure of effectively digging holes that you don't need to. It also improves that data, so really drawing on that kind of trusted data source, so allowing you to make accurate decisions, achieving that compliance across the business in a single source of the truth, and ultimately improving your customer experience, so you're not affecting or impacting your customers, or if they are impacted, reducing the time that impact is kind of pushed upon them. And all this will lead to an improvement of the overall process. So efficiencies, as I say, organization-wide. It gives control to the utilities, so they are no longer at mercy of a third party. And it allows consistency and compliance again, because we've automated these kind of shared business rules, which the utility can improve on and build on as time going on, allowing them to adopt this continuous improvement cycle. So we just got a couple of demonstrations. So that's just loading. So this is an inference demonstration that we've built on the Esri stack. And the solution is platform and data agnostic. So though this is an example, because obviously Esri are a common used platform, we aren't tied to Esri. If you have another kind of data source, another GIS within your utility, the solution can be deployed within inside that as well. So don't fret. So here we've just got an example of a classic network. So here's some properties. We've got some assets here. So maybe clean and waste water. Ooh, let me just leave this guy. And then we've got our tool here. So this is the OneIntegrate for ArcGIS widget here. So the OneIntegrate for ArcGIS is basically a pocket-sized OneIntegrate that can be deployed with inside pretty much any GIS, as I mentioned. And here we have the power, so we can run some validations over the network. So we've got a choice here. And these are all rules that have kind of been designed and implemented collaboratively with the utility. So as I mentioned, the utility has control of these. They can deploy as many as they want. And then we've got our enhancements. So here we're looking at kind of building in this case a water example, those missing assets. So we click that on, we'll just process this extent. So if I hit process extent, what's that is now doing is that's going off and that's running all of those rules and those actions across the network. And then we can see just a very simple example. So we've now got, whereas we didn't, so in areas outside of the extent, you can see it's still missing the service pipes, but we can see that we've now built supply pipes for both networks. So we've got inputs to the properties, and all of this has kind of been derived from information known and the assets that we've kind of built on. So we can even see like inputs to the house, classically where they go, so meeting service reference points, and we've got our drains, which may be privately owned because we're on the property, but we've also got these pipes, which are utility-owned supply pipes up to the board of the property. So it's these bits that the utility will have, will be strict owners of, and they will have to control events that happened. And classically, if you're in the water industry, it's at points like this, so T-junctions, that material tends to get trapped and causes blockages, which leads to further issues. So knowing the point of where these supply pipes meet the main trunk is actually critical on multiple stages. So that's just a quick example. And there, we've got another example, building on, as I mentioned before, we are a third-party reseller for Vertigis's GeoCortex. So again, looking at a very similar network, just play this. But again, trying to emphasize the kind of, we can deploy in any platform. So this is inside GeoCortex, where we're going to run some kind of enhancements. So here we're saying, okay, we want to create some assets dependent on what the kind of area. So we hit, okay, I want to create some missing assets. What extent do I want? In this case, we're choosing the full extent. So that's quite a lot of data. And it's worth probably emphasizing that it's not strictly, we don't have to always target the area. We can have this running server side. So it runs over your entire data estate. It's just quite handy to show in the GIS that, say, a new building estate gets built, that we can actually go in and we have manual control of this. So both taking advantage of that kind of automation process that you can trust in the background, that will just go and do it for you, and you come into work and it's inferred, you can trust that information. Or we can take a kind of manual look and go, right, I want to look at this particular area because it's an unusual build or whatever it might be. So again, empowering the utility, empowering those users or field users, because it can be operated on a mobile device in the field, to try and infer and increase the efficiency of the overall process. And as I mentioned as well, it doesn't just stop at physical assets. So we're not just concerned with where the location of my pipe is. We're also concerned with the location of assets around it. So here we've got an example of non-network data discovery. So it could be as simple as land parcels, so individual parcels for properties, or it could be address information, so inference of, in our records, we're missing addresses, so we need to know where they are, or multi-occupancy buildings, which is particularly relevant for the gas industry. Where are we feeding multi-occupancy buildings, which we need to be aware of, because there's obviously multi-people living in that property, which makes that property high risk. So if there is an incident in the area, we're going to have lots of customers affected with inside one property. And if there's a dangerous event, we can react appropriately and speedily to cut the gas or take the operational step that's required depending on the property. So knowing where those non-network assets are equally as important. And just to finish, just a couple of success stories that we've kind of done in the past. So we worked with Northumbrian Water, where there were kind of financial savings of 8.75 million, time savings of 3 years, and an overall project reduction of 87%. So when they first kind of looked at, okay, well, how are we going to infer the service pipes that we've inherited for the main trunks that we now are responsible for. It's going to take us a significant amount of time and a significant amount of cost to go and do it manually. Is there an automated way we can do it? And as you can see there was a significant financial saving, time saving, so a real benefit for Northumbrian Water. And a similar operation was performed with United Utilities. So there was a financial saving of roughly 10 million. They found an additional 60 million assets using our approach, which is a considerable amount of assets. And there was a 24% improvement in tracking of these transferred assets, so knowing their location, which really helped utilities take control and gain a full picture of their network. And that's it. So thank you for your time. If there are any questions or any hands raised, now is the opportunity. I can't see any hands raised, and there's no questions in the text box. Okay, well, if you do have any questions, my contact details are on screen, so please feel free to fire through any questions you may have. We're always happy to come and show you a live demo of the full process, to show you some kind of snippets there. And again, thank you for your time and enjoy the rest of your Tuesday. Thank you very much.